So in this video, we're going to take a look at some exponential functions. So first of all, what is an exponential function? Well, in general, it's anything in the form b to the power of x, where b is just a number, right? So if we use our function notation to get us started, right, let's imagine we've got a function like that, okay? Perhaps there's a number there instead. Rather than generalize, why don't we just think about maybe 2 to the power of x? So what does this look like? Well, imagine that we're increasing that x. It goes from 1 to 2 to 3 to 4. What's going to happen to the value? It is going to get what's known as exponentially bigger. Okay, so clearly when x is 0, anything to the power of 0 is 1. So we're definitely going to be crossing that y-axis there, look, at 0, 1. But from that point on, it's going to get bigger and bigger and bigger and bigger and bigger, like that, okay, as we go further and further along that x-axis. Now, what about to the left? What about when x is negative? Well, we know what that means in terms of exponents. If I have 2 to the power of -1, it's a half. 2 to the -2 is a quarter, and then we'd have an eighth, a 16th, and so on. So what's going to happen on the other side is it's going to get smaller and smaller and smaller. But it isn't ever going to go and get negative, is it? We're never going to have 2 to the power of anything give us a negative number. So we're going to be tending towards 0 in that negative direction, like that. Okay, so that's what a exponential function looks like. Now, we say we tend towards 0. What this means is there's something that's known as an asymptote at this line here. Let's draw it in a dotted line. That's the line that we're approaching, right, but never actually hit. And in this case, of course, it is the line y equals 0. It is the x-axis. Now, lots of these functions, they all look very similar, right? Okay, if we think about 3 to the x, do you know what? It's going to be pretty similar. Okay, it'll go a bit faster up. But do you know what? It's still going to cross at 0, 1, isn't it? It's still going to have the same general shape, right? 4 to the power of x, that's going to be a bit steeper again, but it's going to have the same general shape, right? All of these things do. Now, we could look at different shapes with the lens of transformations of functions, perhaps, but we can also think of this in other ways as well. Now, so let's start off by saying that f of x is equal to, let's say, well, we used b earlier, let's say b to the power of x. Okay, and we've got our general shape, right? Okay, it looks like that. So what would happen if we wanted to find, let's call g of x b to the minus x? So in other words, in fact, rather than using g of x, let's say it's f of minus x. Well, that is going to be, if you remember your transformations, a reflection, isn't it? Right? Okay, when you have a negative x there, it's going to be a reflection in that y-axis. So what this is going to look like is that, okay? That's our shape when we have a x being a negative. Now then, what about if we think about f or minus f of x, perhaps? Okay, well, that would be minus b to the power of x. Okay, so that's going to be a reflection too. That is going to be a reflection in that x-axis this time. So we're going to change that original function. A reflection in the x-axis is going to look like that. So that will be the general shape if we have that. Now, just following on from this, there's a few other facts I'd rather just sort of explain. Okay, you can work these out for yourselves. Okay, so if maybe our general function, look, is something like this. Well, this works just like other transformations. This d is going to move it up and down, right? Okay, a vertical translation. If I swap x for a x minus c, that's going to move it to the left and to the right, okay, just as any other transformation would. A is going to stretch this thing, right? Okay, so if x is negative, well, we're going to, sorry, a is negative, excuse me, we're going to be contracting it, aren't we, right? Okay, so with all these values, we can be working out the shape, the general idea of the shape, all right, just by thinking through that lens of transformations. Now, let's jump into an example. So here we've got the graph of y equals 2 to the power of minus x minus 3. Now, I think to help us to explain what this graph is going to look like, let's start off with this graph. This is y equals 2 to the x. Okay, and we know all about this graph. We know that it is going to cross there, look, right, at 0, 1. We've got this asymptote line there at y equals 0, that x-axis. Okay, so now that we've got that graph, and that's our starting point, let's think about how we can turn that graph into this thing that we want. So first of all, we've got that 2 to the minus x. So if we're replacing an x with a minus x, that's a reflection in that y-axis. So our graph is going to come like this, all right? That's going to be y equals 2 to the x. It's just a reflection. We have still got that asymptote line there. We are still crossing at 0, 1. Okay, so but from there, maybe we can go a step further and now think about what would happen if we minus 3. Well, that's going to shift this graph down. Every value, every outcome of 2 to the minus x, we're going to take 3 away from. So that means it's going to go down. So rather than that asymptote line being at y equals 0, well, that asymptote line is now going to be at y is equal to minus 3. But apart from that, the shape of this thing is going to stay broadly the same. We're going to be looking like that. Now, where does it cross this axis? Well, it doesn't cross at minus 3, of course. It didn't cross at 0 before. It's going to cross at 0, minus 2, 1 up from that asymptote line, just as this one was 1 up from the asymptote line earlier. So there is my function, y equals, let's write that down, shall we? So that is y equals 2 to the minus x minus 3. Now, next part, we've got to find the range and domain. Let's do this graphically. Now, if we remember what the range and domain mean, the range is the outcomes, whereas the domain is the inputs. So what I mean by that is, let's start with the domain. Okay, well, that is the values we can input in as x. And you can clearly see, look, that every single value of x forever and ever has an answer. So that means that x belongs to our real numbers is going to be our domain. What about our range? Well, range is a little different, okay, because of course, what can our outcomes be? Well, that's our y's. So our outcomes, our y coordinates, well, we're never going to go underneath that y equals minus 3 line, are we? If you think about that y-axis, every single one has a solution, right? But not unless not underneath that line. So our range of values is going to be y is greater than minus 3. Okay, now I haven't used set notation there. I'm just going to describe them in a sort of rudimentary way so everyone can understand. Okay, but that will do for now, right? Domain, x belongs to real values, and the range is y is greater than minus 3. Okay, hopefully that's helped you to understand a little bit more about these exponential functions, and you can now attempt